together with the angle should be maintained constant. So in this section, you see from the first question, we have looked at a scenario whereby we were supposed to state how the temperature can be varied. We said a hot plate and a cold water bath could be used. We also looked at to justify the choice of a digital thermometer, and there we say that a digital thermometer does not have error of parallax, and also the digital thermometer has a higher resolution than a liquid in thermometer. To identify control variable in that case, experiments volume should be kept constant and also the mass should be kept constant. Describe how the variable can be controlled. Anytime you are given a question and you are supposed to work out or to say the control variables, you look at those quantities which can affect the performance or the result. Right, rate of flow, we said volume over time. In that case, for those who are joining, this is what we have already mentioned. So the next part that we are going to move is question number 3. Describe how the student could ensure that the intensity, we have said that the student should place the lamp at a fixed distance and also ensure that the angle of inclination of the lamp to the solar should remain the same. State the method the student could use to increase the temperature using a water bath and a heater, and also to heat the water, and also use an immersion heater in that case, or an electric heater in that case. At room temperature, the student measured the potential difference to be 2.74 and the current to be 45 milliamperes. We are supposed to calculate power, so we were to remember that power is current times voltage, but you also need to remember that this is 45 milli, so you have to multiply by 10 raised to power -3 so that you can convert it to amperes. Well, once you've worked out, you'll get 0.12 watts. They measured the intensity of light incident on the solar cell, and that was 200 watts per meter square. We are supposed to calculate the efficiency of the solar cell at room temperature. So the first thing that we need to understand is that intensity is usually power over the area. But we don't have the area. We can be able to work it from here. You can be able to convert these millimeters to meters so that we can be able to say power is equals to intensity times area. So working out the area, we shall get 3.6 times 10 raised to power -3, and the intensity was provided, so the power was 0.72 watts. Energy is useful power output over total energy. So to calculate the efficiency, efficiency is going to be useful power output over total input times 100, and if you work it out in a percentage, you'll get it approximately 17%. Anytime you'll be given tables in this exam, something that you need to remember, you will be told to criticize the result. So to criticize the result, you are going to look at the consistency of the decimal places and the number of significant figures that are given. So if we can look at the data that was provided here, we can notice that there is inconsistency in the number of decimal places and significant figures in the I column. And also we can look at their few readings. In order to draw a graph, in fact, you need more data. So the data that is provided is less, and also inconsistency in the decimal places in the current values, and there are a few readings, and We can also inconsistency in the interval of temperature reading. So from here it's 5, here you can see it's 10, then here is the interval is 20. So that inconsistency is not going to really make us get accurate results. Over range of temperatures shown, the relationship between power output and the solar cell and its temperature is linear. Describe how the student could use a graph method to determine the rate of power output. So we're going to say they need to calculate the power output at each temperature and then plot a graph of power against temperature. That is going to be a straight line graph. Then in order to get the rate of change, the change in power output, need to work out the gradient in order to get that. Basically that's what we're supposed to do, work out the gradient, and also remember that you are going to plot a graph in order to get that result. When an object is in contact with a horizontal surface, there is a maximum frictional force F, and this frictional force F is given by this relation here, where mu is the constant, n is the normal. Now the question that we are asked, describe how the student can determine F, and the situation shown here. The student should increase the slotted mass until the rubber stands to slide, because we are trying to find the force that can make this to start to slide. So we keep on adding the slotted masses until it starts to slide. And then to calculate the frictional force, we need to work out the force is equals to mg, because now the force is equivalent to the weight of that object. So you can write in the comment section if you're getting value, and also let me get to know whether you are benefiting of what you are doing. If you're new to ProfLearn, consider subscribing, and also check in the Patreon page whereby you can be able to download this paper. Right, so moving on to the next part, explain how the values of n are calculated. And you can see our n is the normal reaction force. So we are going to add a mass m to 250 gram rubber block. So in order to calculate that, we are going to say add a mass m, that mass should be in kgs, to 0.25. I converted the 250 grams to kilograms. Then calculate the weight using the formula weight is equals to mass m plus 0.5 times gravitational field strength, which is 9.81 in that case. When you are plotting the graph, you have to ensure what's on the y-axis as you are told, and what should be on the x-axis there. So that's why you can see I ensure that the force n is on the force is on the y-axis, and we have n in the x-axis. So we have our force there on the y-axis, and we are supposed to determine the value of mu. If you can see, whatever we have gotten here is a, okay, there is maybe something I need to mention here. I circled one of the points, and I'm going to consider this as an anomalous point. so that if there is any point that is out of the line and not really consistent with the rest of the values which are there, you need to circle that to indicate that's an anomalous point. Remember we were told here that the equation that connects force is this. So which means if we relate this equation with y is equals to mx plus c, this is having 0 y-intercept. So meaning if you draw a graph of force against n, it's going to be a straight line that passes through the origin. So that's why you can see the graph we have obtained down here is a straight line that passes through the origin because force is proportional to n. And then which means that if we want to find the value of mu is going to be the gradient of the graph, which is going to be 0.58 in that case. And 0.58, this mu is not going to have the units. The tire manufacturer carries out a similar test for the sample of rubber used to suggest why this is necessary. Can you state why is it necessary? This is done to test if the tire will provide enough grip or enough friction in order to stop the car in the same distance. So basically that's what we are supposed to do in this paper. You need to remember that there are more formulas which I provided down there for you to use, so you don't have to really struggle in order to remember most of the formulas that were done in unit 2 and in unit 1, that is mechanics and materials. So up to that point, this is the it's quite strange that I was explaining most of the concepts, I think, and it wasn't displaying at the other end. So I think I need to ensure that I run you through what I was saying by the time the display disappeared. I don't know at what time did the display disappear. All right, so let's look. Maybe the display disappeared. Yeah, this one I mentioned the display might have disappeared when we were talking about this. So there's inconsistency in the interval of temperature, because you can see from here to this is 5, from here to here is 10, from 30 to 50 is 20. So that inconsistency in the temperature can really affect the results. Inconsistency in the number of decimal places in the current. You can see here we are having 1 decimal place. Here we are having 2 significant figures. So there is inconsistency in the number of decimal places as well as the number of significant figures. So there are a few readings. So this data is not really enough to draw a graph and get the accurate curve of best fit. Over the range of temperature, we have shown that need to calculate power output. In order to discover, the student could use graphical method to determine the change. So for us to determine the change, we need a graph, and the graph should be the power output for each temperature. Then plot a graph of power against temperature, and then the rate is going to be the gradient of that graph that you are going to get. Also, I was talking about an experiment whereby was trying to determine which amount of force can be able to move this. So describe how the student could determine F. This F we are talking about, the force. F is what? F is frictional force, yeah, but that frictional force will be equal to the force that is pulling down here, right? So for us to determine the frictional force that is pulling backward, we need to add slotted mass until it starts to move. So we keep on adding the slotting mass until it starts to slide. Then to calculate the frictional force, we use the frictional force is equal to mass times gravity. The slotted mass times the gravitational field strength, which is 9.81. explain how the value of n is calculated. Remember, n is the normal force here, normal reaction force. In this case, there was the 250 rubber grams, so we have to add the mass, keep on adding the mass so that we can be able to vary the force there. So we're going to say add the mass m in kgs to 0.25 kg. Remember, it was 250 grams, so I had to convert this to kilograms so that I can be able to calculate the weight by mass plus m plus 0.25 times the gravitational field strength. So when you are plotting the graph, ensure you know what should be on the y-axis and what should be on the x-axis. And if you have any point which is inconsistent with the rest, you can be able to circle that point to show it's an anomalous point. You did not consider it when you are drawing the line of best fit. So if you look at the equation that we are given here, f is equals to mu n, so meaning the y-intercept is 0, and if we relate this equation with the equation of a straight line, it will mean that the constant mu is basically the gradient of the graph that we are going to get at this given point. So if we work out the gradient of the straight line that we got, we shall be able to get the value of mu. In that case, the gradient is going to be, you shall use a big triangle more than three quarters of the straight line, about 3/4 or more, and then we can be able to get our answer 0.58, which is the value of mu, and it doesn't have units because it's a constant. So, right, so the tire manufacturer carries out a similar test on the sum of the rubber used for tires. Suggests why these tests are necessary. In this case, we're going to say this must be done to test if the tire will provide enough grip in order to stop the car in a safe distance. Yeah, so that will mark the end of that paper as you are preparing for your exam. So shall be having another tutorial on the same tomorrow, the last bit, which can enable us understand how you're supposed to work out more of those questions. See you tomorrow for the next bit, the final tip, and also my final advice on how you're supposed to score more in this paper. See you in the next video.